Okay, think about this for a second. Breathing. You're doing it right now without even thinking about it, right? We do it thousands of times a day, but this simple automatic act is probably the most critical thing keeping you alive from one second to the next. So let's dive in and actually follow the incredible journey of a single oxygen molecule to see why your very existence hangs on it.
It's a wild thought, isn't it? Our bodies are amazing at storing energy from food, and we can manage for a few days without water. But air, oxygen, you've got minutes, maybe. The clock starts ticking immediately. And in this explainer, we're going to find out exactly why the stakes are so incredibly high.
All right, so where does this all begin? Well, it starts right here, at the gateway to your body, your lungs. Every single breath you take pulls a little piece of the outside world deep inside of you, and that kicks off this whole microscopic chain reaction that powers, well, everything.
So you take a breath, and that air gets pulled down your trachea, your windpipe. From there, it splits into two main branches, the bronchial tubes, one for each lung. And these tubes just keep branching and branching, getting smaller and smaller like a tree, until they end in these teeny tiny clusters of air sacs called the alveoli. And this is where the real magic happens.
Okay, now check this out, because this is the brilliant part. This whole exchange, it takes zero energy from your body. It's totally passive. See, the air you just breathed in is packed with oxygen, right? But the blood showing up to the party is low on oxygen and full of carbon dioxide waste. Just because of that simple difference, oxygen automatically jumps from your lungs into your blood, and the CO2 jumps out of the blood to be exhaled. It's an elegant, effortless swap.
All right, so the oxygen has made the leap. It's officially in your bloodstream. But now what? How does it get from your lungs all the way to, say, a muscle cell in your big toe? It needs a ride, and that brings us to the body's incredible transit system, the Oxygen Superhighway.
Meet the hero of this part of the story, hemoglobin. Seriously, you can think of it as the ultimate dedicated taxi service for oxygen. It's this amazing protein, and every single red blood cell is jam-packed with millions of them. They grab onto oxygen molecules in the lungs and just hold on tight until they get to a part of the body that's desperate for it.
And this chart just drives the point home. I mean, look at those numbers. A tiny, tiny 2% of oxygen just dissolves into the blood. But the other 98%, the overwhelming majority, hitches a ride on hemoglobin. Without this taxi service, our blood just couldn't physically carry enough oxygen to keep us going. It's absolutely essential.
So after that wild ride on the superhighway, our little oxygen molecule finally arrives. It's at its destination, one of the trillions of cells that make you, you. And now we finally get to the big why. Why did it go through all this trouble in the first place?
This is it. This is the whole reason you breathe. Your cells need oxygen for this process called cellular respiration. It's basically how they take the food you eat, things like glucose, and use oxygen to burn it in a really controlled way. And that slow burn is what unlocks all the chemical energy that was stored inside that food. Now that energy that gets unlocked, it's stored in this amazing little molecule called ATP. Honestly, the best way to think of ATP is as the energy currency of your body. It's like a tiny rechargeable battery. Every single thing you do, flexing a muscle, thinking a thought, healing a cut, it all gets paid for with ATP. Making ATP is the entire point of the whole process.
And this chart, this right here, shows you why oxygen is a total game changer. Without oxygen, your body can still make energy, but it's super inefficient. It can only squeeze out about 2 units of ATP from a sugar molecule. But with oxygen, boom, you get up to 32 ATP. That's a staggering 15 times more efficient. It's this incredible efficiency that allows us to be big, complex thinking creatures.
Okay, so we've seen how perfectly this whole system is designed to work. It's beautiful, but what happens when it breaks? When that constant flow of oxygen just stops? This is where things get serious, and we have to confront the reality of that question we started with. The first thing to feel it, the most vulnerable organ by far, is your brain. Get this, your brain is only about 2% of your body weight, but it is an absolute energy hog. It guzzles down 20% of all the oxygen you breathe in. All that thinking and processing and running the show requires a massive, non-stop supply of ATP, which means a massive, non-stop supply of oxygen.
And the consequences of cutting off that supply are brutal, and they are fast. We're talking 1 minute, just 60 seconds. And brain cells, starved for the energy they need, actually start to die. After 3 minutes, permanent brain damage becomes likely. And by the 5-minute mark, the damage is so widespread that death becomes imminent. This is why you can only last minutes without air.
So let's just take a step back for a second. We followed this molecule all the way from the air around us, deep into our lungs, onto that hemoglobin superhighway, and finally delivered to a cell to create the very energy of life. It's a constant, silent miracle that happens with every single breath.
You know, this quote from our source material just nails it perfectly. Oxygen isn't just something we happen to breathe, it's the final, non-negotiable ingredient. Without it, the whole energy production line grinds to a halt and the tiny engines in our cells just stop.
So every breath is an opportunity. It's a fresh delivery of fuel for thought, for movement, for life itself. It really makes you think, doesn't it? Knowing the incredible journey that little molecule takes just to get to your cells. What amazing thing will you choose to power with your next one?